I just looked it up in too. Okay. So let's have to do it with the battery going off first. Makes my voice all scratchy. Okay, 211. Number 5. What do the directions say? 5. We learned 2 different methods. Already graphing, elimination. This one's different. Substitution. So on your paper, will you label it? Solve by substitution. Solve by substitution. So you know the different methods, and you have an example to go back to. I'm going to write it down. The 2 equations it gives us. Okay, so elimination, we've only eliminated one of the variables. We got y that we cancel out by adding up all y terms. We have to add multiply by -1 to make one of them positive y, one of them negative y. Here, we're going to identify the equation that is solved for one variable. Which one's already solved for one variable? Is it both? Are both of them solved for one variable? Yeah, this one's studied for the y. This one's solved for x. But you see one of them, at least one of them solved for one variable. We want to take that one and we're going to substitute it in. Substitute the equation in wherever that variable exists in the other equation. So I'm going to take the one that looks a little nicer. This one that has an x equal L. Anyways, it's about the same. So I'm saying I'm going to put it either way. X equals, so what does x equal? Y plus 80. So whenever there's, yeah, I just changed my mind. I think doing the other version would be better. So, we're going to go with this one, because I don't have to square that. I'm going to take this one. Instead, I'm going to take the y. What does y equal? It equals this, right? Remember how on number 1 when we graphed them, we had a parabola and a linear function? Where were the solutions? We had 2 functions. They would intersect here and here, right? And when they intersect, they are equal. So the x right here is the exact same as the x on the quadratic. The y right here on the linear is exactly the same as the y on the quadratic. They're equal. So in order to find solutions to solve, we must know these are equal. So I'm going to take this trinomial right here. Since it equals y, I'm going to plug it in that y. I'm going to replace or substitute this y right here with the y above. Okay? That's what substitute does, right? When I'm done, or I need to change it on it and substitute, come and replace them. Substitution. X equals something plus 80. Instead of y, what should I plug in? Better? Good. Good. So this was equivalent to y. So you substituted y with that trinomial. Does that make sense? Yes or no? Okay. Notice, are there any y's now? No, so we have one equation and only one variable, which means we can solve it. It's a quadratic, so we're going to solve by getting a equal to 0. So solve the quadratic. We want to get it in the standard form. Ax squared plus bx plus c. Make sure it's set equal to what? 0 and then 2, okay? But notice it's easier for us to solve when it's a positive ax squared. This one right here is a negative x squared. So how do we make it positive? Okay, true, yeah, that's a different option. I was thinking move everything, that's probably quicker. We could take all this stuff and move it over, or we could also times everything by -1. Or actually, I like that idea better. I think that's less work. Let's do that. So we must times everything, including this x on the other side. Times everything by -1. So we have negative x equals, and what if you tell me what we're doing here, one times everything by -1? X squared, good. Good. Excellent. Okay, so everything just changes sign and now we're positive, so that's great. We get equal 0 on the other side. So great, how do we get equal 0 over here? Exactly, add x. Now when I add it on the right hand side, should I put it underneath the x squared? Or should I put it underneath the x to the first power? Those linear terms. So 0 equals x squared plus, now we have x and x, which makes 2x. And these guys right here are like terms. Negative 99. Okay, we just had a quiz on this. How can we solve this quadratic? We didn't have any method to solve this quadratic. Okay, 2 people, 4, 5. There's like 30 in here. We just did a quiz on that for one of the methods. How to solve this? Okay? Okay, we have that here, we have to add it over there. That would start you off for completing the square, which you can do. There's one of my other methods that's shorter. There's 4 different methods to solve quadratic. Today we're trying to put them here. So yeah, I think I can tell. You can't totally do quadratic formula. If you move the 99 over, you would be set up for completing the square. What you can still do is just more work. Okay? Let's just do tic-tac-toe. Okay? Come on, can you tell me what goes across the top? And then we add 2. Good. Okay, Riley, what fills in these boxes for A, C, and A times C? So just the number 1. What about C? A, B, C. Just take that to the D is 2. A, B, C. Let's do a free position. A, B, C. There you go. And we multiply that 1 times negative 99 is just negative 99. And what's the middle number for B? A, B, C. 2. Okay. Tell your neighbor, please, let me figure it out. 2 numbers that multiply to negative 99, but add to positive 2. Tell your neighbor when you figure it out. 2 numbers that multiply to negative 99. If I see a repeated digit like that, like if there's a 77 or 88 or 99, it automatically goes to a certain factor. And adds to positive 2. I didn't hear very many people tell their neighbor. I heard a little discussion here. Did you guys all tell your neighbors? Okay, back row, east of the floor, McNeely to Clinton. Let's look them up with. The back row? Let's look them up with. So we're at the -9. Does that multiply to -99? Does it also add a positive 2? Yes. So corner x's with the great common factors. Okay, Elizabeth, can you tell me our different ones? I just do those ones. Okay, what about this one right here? 11 and this one? Good, -9. We know the row 1 has -9 has to give us -9. Okay, so 0 equals, don't forget the 0 equals. Shaylee, what should I put in these parentheses now? Uh-huh. So is that positive number or negative number? So we'll put plus, and then good. Okay, if they're not the solutions though, they're giant factors, so let's do another step. Okay, we saw this one in the corrector quiz. What is it given? Squiggly line. Equaling to 0, this is the 0 property. You should probably be able to see these. Instead of going through all the algebra, you should be able to see this. Okay, Jane, what's our solution here? What number plus 0? -11. It's just the same number, but a different sign, right? Jackson, what about this one? What's the solution? What number -9 of 0? X equals plus 9, yes. Okay, so there are our solutions. Yes. Because positive 9 minus 9 would be 0. Right? They have to be opposite, so we're going to be 0. That's why it's opposite signs. So, this again was, where is it? Way up here. Substitution. Which has one of them, so I actually ended up taking out the one that was more complicated. One that was more complicated, I took its value for y and plugged it in for the y in the less complicated equation. And we got all the variables to one side and just solve the quadratic like we know how to do. Okay? There's one more method, which is a super easy method. So you can now do 4 and 5, or you can now do 4 and 6. And we're going to skip down to 7. So leave a spot for 6. We can say number 5. Leave a spot for 6. We're going to do number 7 together. And then you should be able to do the rest of this assignment. Number 7. Solve using a graphing calculator. If for some reason you don't have a calculator, come get one. So if it's spot for 6, you can see it doesn't, it needs a little bit of room, because number 5 took a little bit of room. And then write down number 7. Oops. Okay, look at that calculator. This is super easy. As long as you know how to use your calculator. Okay, I'm going to put this here. Oops. And then I'm going to put this. I wrote it wrong side. Not me, but like this. Cut that. So I'm going to put it over here. Oops. Okay, there's number 7s. And here's your graphing calculator. Alright. All we have to do is go put this in our calculator. The calculator can tell us the solution. You're allowed to use this method, the directions tell you to use this method. So on your calculator, open it up, turn it on. Everyone needs their own personal calculator. I'll get one if you don't have one. Go to the y equals button. You see y equals? On the top left. Okay, good. Get back in there and clear it out. Okay, and you know how to do your graphing. Okay. Now we want to put in both equations. The first one is linear, so we're going to type in x minus 5. The x value's up here by the alpha button. X, make sure you use the actual subtraction button, minus 5. So we have to do the other one, arrow down. And type in x squared. X squared is diagonally up from the 7. X squared minus 6x plus 5. Okay. Now, to make sure all of our windows, to make sure our windows are the same, we're going to go to Zoom, which is right here at the top, in the middle. Put Zoom and look for Z standard. Z standard. That's a standard zooming window from -10 to +10. Zoom, which one's Z standard? Which number? 6. You can just type the number 6. You can also arrow down to it and press enter. Everything typing 6 is faster. So it will set the graphic for you. There's the first function that's linear. And here's that, oops, did I do a cubic? I must have put a, I did do a cubic. We'll learn about those next year. I didn't insert, oops. Then click INS, go to the delete button, that's insert. Second, insert my minus sign. Aha. Then I can just push graph, because my window's already okay. Okay, that's the linear. Here's the quadratic. How many solutions are there? Meaning how many intercepts? 2. Just so you can see that I really am going to get in closer. You don't have to do that. I just get closer so you can see the next step. So essentially, we went to, on the calculator, we went to y equals and insert in the equations. Then we went, make sure our window was good, we went to Zoom, which select the number 6, Z standard. Now we're going to have the calculator calculate for us. You see on the top row, anything that can calculate? The top row? What is about the top row? Trace. What's about trace? What does it say? Calc. Now. So we're going to select calc, but since it's in blue, or when we have it in yellow, we have to go hit the matching color first. We have to go second trace. Second trace. And you get a list of options. The first one calculates any x value, and it'll say the y value. The second one gives you zeros. What's another name for zeros? It's a very test. Roots. Swing. X-intercepts. And solutions. It's a very test. Then we can get minimums and maximums, but the one we want is number 5. What does it say? Intersect. So push number 5. 5 intersect. Now on the bottom left-hand corner of the screen, it says first curve. If you move your arrows left and right, blinking bug that's crawling along the first curve, which is the linear function. We want to arrow it over until it's on the first intersection point. Oops, what did I just do? Delete that. It's not like this. Okay, so I'm going to do the left one first. The lower intersection first. So arrow your bug right and left, depending which way your bug is, until it's on that intersection point. When it's there, press enter. Now you're screen no longer says first curve. What does it say? Second curve. And you just redo this with this. So if you notice, if I go right and left, my calculator has now transported the blinking bug onto the quadratic, which is the second term. You probably don't actually need to move your arrow or move your bug. As long as it's still on the X or on the intersection point, press enter. Then it says guess. As long as your bug is there on top of the intersection point as close as possible, press enter. So essentially you push enter 3 times. And what is our intersection point? So can I write that as 2 combinations of that one up there? Okay. Now you're going to go back through and get a second point doing the same process. So eventually you hit enter 3 times. So, because this is your homework, I'm going to let you go do that one with yourself right now. Go second calc. Which one is it? Number 5. Now you need to go left and right until your blinking bug is on the other solution, which is the other intercept. And then push enter essentially 3 times and write your answer down. And you don't want to forget your calculator. So yes or no? Okay, now let's see if she's figured it out. Here's what I'm saying. grade. So, you guys have more than half of this done, page 211, numbers 1 through 12. When you take the graph papers that you've already worked on, put them inside your book right there and close it up. We're going to do something different. So we've done most of that assignment for you. So put the graph papers, if you have blank graph papers, keep the blank graph papers out. The graph papers you've already written on, close them up in your book, and put your book in your bag. Okay, please. If you have blank graph paper, you still need it out. You guys have blank graph paper? You still need the blank graph paper out. Please close up your book. Please close up your book. The graph paper you've written on, just close it up in your book. And the blank graph paper, keep it out on your desk. Actually, in my mind, you can just take that graph paper for that homework. Then just start right on this assignment. Let me do it right on your homework. And change my mind about keeping my graph paper out. But you want you close up your book and put your book away. That's what we're doing right now. Okay. Okay, let's look at this one. Oh, this was good. I'm going to print it in that room. I printed the pressure reports. Usually, that was when I forgot about it. Thanks. Your name on your worksheet? It's coming slowly. Please as well. I'm going to wipe it over here and I'm putting the date on this whiteboard in case you report. Oh, it's so slow today. There we go. The codes and half the rules give them at the very end. Okay, here we go. Thanks for your patience. It's very slow processing that. Alright, if you remember, back in junior high, when you solved inequalities, the unsmart inequalities, look at what's different about this system. Is it an equal sign anymore? Like the ones we were just working with? No, less than and greater than. So on the top, would you put a key? What is that symbol? Does it look like an L? Can I put ESS with it? Does it look like an L? It's less than. Does this one look like an L? Can I put ESS? Is that sort of word less? No. So if it doesn't look like an L, that is greater. And in junior high, when you graphed inequalities, you did them on a number line, one-dimensionally. And so say you graph 5 is greater than, or x is greater than 5, you have like open circles and then you did arrows. Remember that? You had closed circles sometimes. So you did open circle when it was less than and greater than. When do you do the closed circles? Equal to. Extra line for the extra fill. Extra fill, extra line. So something similar happens with inequalities with two-dimensional graphing. Instead of a solid line, though, we do a dotted line for the open and a solid line for the fill. So when you show me those, solids like this, solids like this. Okay, dotted, solid. Okay. So let's go through number one. We're going to graph. Grab one of your pencils, please. And if you could highlight, shade lightly. Shade lightly the first one. Grab a colored pencil. And pass them out. You have a red box. There's a box in your row of colored pencils. Why would that not happen? Okay, now I just colors the pencils. Okay, this is linear because it's x minus 1 and x plus b. Remember that constant is your y-intercept. That's the first thing you want to graph. In front of the x is your slope. Rise over run. You use the slope second. So on our graph, we're going to go put a y-intercept point at -1 with your first colored pencil. On the y-axis, we're point at -1. Okay, and then look at the x. Usually, how many x's are right here? How many x's? Right here. How many x's are right there? 1. Is that the same thing as 1 over 1? Yeah, so that's rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. All the way until you're off the graph. But we also reverse it and go down 1, left 1. Down 1, left 1. It should look linear. But before you draw a line, look at the sign. Please show me. Is it going to be a solid line or a dotted line? It's solid if there is an equal to. It's dotted if there's no equal to. So it should be solid or dotted. I don't think many people should be. There's an equal to, so it is solid. So take your ruler and connect this with a solid line. Now there's more we have to do. We need to also shade. Because inequality comes from one solution, there's infinite solutions. Every point on this solid line is a solution that makes the inequality true. But there's also other points. The other points are either above this line or below it. We do that by using a test point. We're going to plug in a number and decide if it makes a true statement or a false statement. Then, okay, the easiest number to use is, or point to use is 0, 0. Because we plug in 0, so we're really nice to work with. So we're going to replace this y with a 0. Then we're going to replace the x with a 0 and put -1. And then see that. The y is a 0, the x is a 0. And then just simplify. 0 is greater than or equal to -1. True, this is the team's language, or false. True or false. 0 is greater than or equal to a negative. True or false. True or false. 0 is greater than or equal to a -1. It should be true. 0 is greater than negatives, right? True. So this point right here is true. We're going to shade everything in the true area. So everything above the solid line. So the shades, please shade lightly though. Shade super light. I'm going to get a light pink for my shading. So, all the way up to that solid line, and everything above it, lightly shade. The same color. Yeah. Okay, then, take your second color and highlight lightly the second inequality. We're going to go through the same process. We graph it, and then decide solid or dotted, and do test point to determine where the shade. So the first thing you have to plot is the y-intercept. Let's begin there with the y-intercept for this bottom inequality. Good. Around over here with the y-intercepts. 2. Good. So on the y-axis, the point in your second color on 2. Gosh, I'm gonna know my list says no more interruptions. Thank you. Kevin, this is for you. Okay, then we get some slope. Jason wants some slope. Good, so what does that mean? And then run. Good. So from that y-intercept point, you're going to go down 1 and run 2. Ooh, we have an intersection right there. Down 1, run 2. Also, you can reverse it by going up 1, left 2, up 1, left 2. Before you draw your line, should it be solid or dotted? Solid. How do we know it's solid? Elson? As the equal to. So take your ruler and connect them with a solid. I just get number 2, that bottom one. What would that give us? Solid or dotted? That one will be dotted. Okay? Now, on the blue, we also need to test point. I'm going to use again 0, 0. If you use 0, 0, as long as it's not on the line, then you just drew. If it happens to be on the line, the next easiest one to use is something on the y-axis, because then at least the x is 0. So you don't easier to work with this. It can be any point, but the 0, 0 is the easiest one to work with. Okay, so we're going to, it can be any point as long as it's not on the line. I should make that note. It can't be any point on the line, but it can be anything else. So I'm going to put in 0 for y, 0 for x. So 0 is greater than or equal to 1/2 times 0 plus 2. Thanks for whiskers. So we have 0 greater than or equal to 2. See that cancels out? That's why the 0 is really nice, because it'll give you a cancel. True or false? 0 is greater than or equal to positive 2. True or false? True or false? Is 0 greater than or equal to positive 2? 0 is greater than positive? Is 0 greater than positive? No, it's actually false. So this point here is now false. For the blue line, we only shade where it's true. So the false point is below the line. So let's shade above the line. We only shade where it's true. Again, do this lightly. We shade above the line because any point over here would be true. Now, with the darkest pencil you have, you might need to trade with a neighbor. Where is there both shading colors? To kind of create more quadrants. Where did we get the line both pink and blue shading? On this top quadrant, right? So take the darkest color, maybe swap with a neighbor. The darkest color, and shade this kind of like triangle shape. That is the solution. Okay? Oops. Okay, you can see the comments on your desk, go get them. We'll ask more questions on inequalities next time. Did everyone get their pressure? Okay, that's great. Jake, I have yours. Allison, Mikkel, did you sign? Jackson, Yeager, Cameron, and Clinton. Jackson and Yeager? Oh, wait, Allie? Okay, let's do that. Mikkel, Janique. Complete the color pencils in the box. They're on your desk. Go get them. Mikkel, Jackson, Cameron Sweat here, and Clinton. There you go. Okay, remember, they were confused about the text, which is next frame. You have the zero on anything in your if you want to redo like this stuff, maybe one that's 7 so if you want to redo that, you have a sort of a test. Can you say it?